We're beginning our unit on transformation. Reflections are the first transformation that we learn about. Think about a reflection. When you look at yourself in the mirror, you see a direct, perfect image of the top reflected in the bottom, right? This line here is called the line of symmetry. And if a picture has symmetry, it means if I were to fold this picture right now in half, both sides would perfectly match up. So let's find the line of symmetry in these two pictures. The line of symmetry is right here in this picture. And it is right here. Let's pick a different color. And it is right here in this picture, okay? It's the part where the top is reflected in the bottom, or the left side is reflected in the right side in this case. For this letter A right here, the line of symmetry is right here. If I folded this A in half, the two sides would match up. Same thing with this letter 8 right here. If I folded this letter 8 in half right here, let's do dotted lines, okay? I folded this letter 8 in half this way, both sides would match up. And if I folded this letter 8 in half this way, both sides would match up. So an 8 has two lines of symmetry, and A has one line of symmetry. What about a rectangle? A rectangle, I could fold a rectangle this way, I could fold a rectangle this way. So a rectangle has two lines of symmetry. I could fold a square this way, this way, this way, or this way. So a square has four lines of symmetry. Do you see where I'm going with this? This is what a line of symmetry is. And the line of symmetry is the boss. It is the line that shows us where the image is being reflected over. So let's say that if you could see the ruler that I'm currently working with, you always need to use a ruler because accuracy is very important, especially when you're doing geometric constructions like these. Okay? This may seem basic, but it's a very important skill to master to continue on in higher education. Okay, so here we are. We are going to line our ruler up so that way the little notches where the numbers are is completely lined up with the axis of symmetry or the line of symmetry. So I'm going to draw my guidelines, which will be in orange. Okay, I'm going to draw, oops, hold on. It's kind of hard using a ruler on this thing. Okay, so I'm going to draw my guidelines, which will be in orange. Okay. From each vertex to the other side of the line of symmetry. Okay. It's really difficult using a ruler on this thing. Okay. So it should look like this. Okay. Now I look at the figure on the left and I try to reproduce it on the right. So first, this side kind of slopes up, and that is the line that connects I think I'm not going to be able to use a ruler. I'm sorry, you really need to use a ruler, but for this, using this application, it's really difficult to use a ruler. Okay, so you need to line up the bottom vertexes with the top vertex, okay? And then just look at the figure and try to recreate it on the other side, okay? So this is going to be A prime, this is going to be B prime, and this will be C prime. Now why is C prime towards the center and B prime out here? Because look at the original figure. B prime is on the outside and B is on the outside and C is on the inside and A is on the top. You really just have to look at the figure and try to recreate it in the reflection. Okay? Let's look at this figure down here, okay? Just look at the left-hand side first, okay? I am trying to recreate this shape on the other side. Now let's draw our guidelines. Okay? Hold on, these don't look so good. This is not a good app for transformations. Okay, so I extend my guidelines out here, right? And I want to create this line right here on the other side, right? So it looks like it starts about like 2 centimeters in and then slants out, okay? All right, so I'm trying to create that on that side. And A prime will be up here, B prime will be down here. So now let's try to move this side over to the other side. So it looks like it starts up a little bit out past A and then slopes downward. Okay? And then this is E prime and this is F prime. So our new shape is going to look like this. Our new oh, no, that's our original. Our new reflected shape is going to look like this. Let's do this one over here. So now the axis of symmetry is tilted, therefore our ruler is going to tilt. Now our guidelines are going to look something like this. They're still going to extend through the vertices, but they're going to be slanted because your ruler is going to be in line with the line of symmetry. So here we are. Now it looks as if the base of the triangle is about this far away from the line of symmetry. And it looks like this up here is going to be A prime, this is going to be C prime, and then B prime will be out here. Over here, our ruler is going to line up with the axis of symmetry. Okay. Okay. And it looks like we're kind of going to create this piece, but over on the other side of the line of symmetry. So it's going to come up like this, right? It'll go down like this over here and then come up like this over here. And that's recreating that part on the other side. Now, let's try to recreate this side on the other side. It's going to come up like this, and it's going to go like this. So now our new reflected figure is going to look like this. So this was C before. Now this becomes C prime, this becomes A prime, and this becomes B prime. All right, now let's look at transformations. Let's look at reflections in the coordinate plane. So let's look at this number, okay? It says, graph the image of the triangle XYZ with vertices 0, 0, 3, 0, and 0, 3 reflected in the x-axis. Okay, so we're reflecting in the x-axis. So let's draw our original figure, okay? Our original figure is x is 0, 0. Y is right here. And Z is going to be right up here. Okay? Connect our lines. And we have a triangle. Now, the x-axis is going to be our line of symmetry. So we want to reflect this shape over the x-axis, which means it's just like the figures that you were doing before, where you lined up the ruler with the x-axis and tried to create the picture on the other side. Let's just do this one visually, right? So Z is positive 3. So now if we reflect it over the x-axis, it's going to be 0 over negative 3 down. Okay? This is going to be Z prime. Is x going to change? No, x is not going to change. Is y going to change? No, y is not going to change. And this becomes our new figure. This is this figure just reflected over the x-axis. Now let's look at our original points. Our original points were x, y, and z. Now we reflected these points over the x-axis, and we came up with new points, which were x prime was 0, 0, y prime was 3, 0, and z prime became negative, oh no, it became 0, negative 3. Okay? So what happened from the original to the new points? Look at the y-coordinate here, okay? Y-coordinate started as 0, started as 0, started as 3. What if I tell you that every time we reflect something over the x-axis, we multiply the y-coordinate by -1? Would this hold true in this instance? And yes, it would, because 0 times -1 is 0. 0 times -1 is 0, and 3 times -1 is -3. So what is the axis of symmetry here? The x-axis. What is the connection between the original figure and its image? They are the same. What happens with the y-coordinate when the original figure is reflected in the x-axis? We multiply the y-coordinate by -1. What happens with the x-coordinate when the original figure is reflected in the x-axis? We multiply x. Oh no, x stays the same. Okay, let's look at the next one. Okay, so this time we're reflecting the figure in the y-axis. I'm going to go through it a little quicker this time, okay? So we have -1, 4, and that is A. We have 4, -2, and that's a B. And then we have C, 0, -3 is going to be C. Okay, so here's our original figure, right? And we want to reflect it over the y-axis. So think of this as our line of symmetry, right? Just visually, it looks like we're going to put A prime up here, right? It looks like B is going to be 1, 2, 3, 4 units over and 1 up from C. And then C is going to stay the same. So our new figure is going to look like this. Okay? So let's look at our old points, our original points, right? The originals were A, B, C. A was -1, 4. B was 4, -2. And C was 0, -3. We reflected over the y-axis, right? And we got our new point. Our new point, A prime, was these. So what if I told you that now, if we reflect over the y-axis, we multiply all of the x-coordinates by -1? So think of it like this. When we're reflecting over the x-axis is saying, no, I am the boss. I am not changing. The y-coordinate has to change. And now, when we reflect over the y-axis, The y-axis is saying, you know what? I'm the boss, and the x-coordinate has to change. So when you think of the rule, remember that they're going to be opposite. If we're reflecting over the x-axis, we change the y. If we reflect over the y-axis, we change the x, okay? So let's multiply all of our x-coordinates here by -1. And what do we get? -1 times -1 is +1. 4 times -1 is -4. And 0 times -1 is 0. All right, so here's our rule. What is the axis of symmetry? Y-axis. What is the connection between the original figure and its image? They're congruent. What happens with the y-coordinate when the original figure is reflected in the y-axis? Nothing. Stays the same. What happens with the x-coordinate when the original figure is reflected in the y-axis? We multiply by -1. All right. Now the other type you're going to see is triangle ABC with vertices A, which is -1, 4. Okay. B, 4, -2. And C, right here. Okay. So this is our original figure. And we're supposed to reflect it in the line y equals x. So our original thing, -1, 4. B, 4, -2. C, 0, -3. These are our originals. Okay. We reflect over y equals x, and now we get our new points, okay? So the rule for y equals x, for reflecting over the line y equals x, is that we just switch the x and y coordinates. We switch them, okay? I'll show you what happens. So now y becomes x and x becomes y. We switch x and y. And our new coordinates become, A prime will be 4, -1. B prime will be -2, 4. C prime will be -3, 0. Okay? So let's graph those. We have A prime is 4, -1. B prime is -2, 4. And then C prime is -3, 0. So C prime will stay the same. So here is our new figure. Okay. And I'm going to show you the line y equals x is this line here that passes through the origin. So it makes sense that if we were to reflect something over the line y equals x, that the x and y would reverse. So what is the axis of symmetry? Y equals x. What is the connection between the original figure and its image? They are congruent. What happens with the y coordinate when the original figure is reflected in the y-axis? Oh, this is supposed to be the line y equals x. This is supposed to be the line y equals x. What happens to the y coordinate? They switch. Okay? Last but not least, let's graph this triangle here. Okay. Here's our figure. And its image is under a reflection in the origin. Okay, so reflection in the origin. What's the origin? The point 0, 0, right? This is our point of reflection, okay? So this is the origin. So if we're reflecting something over the origin, where do you think it's going to end up? Let's see. Okay, so if we have our original coordinates, we have original okay. We have reflect in the origin, right? And our new points are going to be, when you reflect something in the origin, you change both signs. So you multiply the x coordinate and the y coordinate by -1. So now we get 2 times -1 and -4 times -1. And our new coordinates become Our new coordinates become -2. Let me label this. Become -2, +4. Okay. M, if we multiply -4 times -1 and 2 times -1, we get +4, -2. And for n, if we multiply -3 by -1, and we multiply -4 by -1, we get 3, 4. Okay? So we multiply both x and y coordinates by -1. Okay? And that's how we reflect something in the origin. And what do we get as our new figure? Let's see. We do, this is k prime. This becomes m prime. And this becomes n prime. And that is a perfect reflection over this point right here. So what is the point of symmetry? It is the origin. What is the connection between the original figure and its shape? They are congruent. What happens with the y coordinate when the original figure is reflected in the origin? Multiply by -1. What happens with the x coordinate? Multiply by -1. Okay, so this is just a basic summary of all the rules that we just went over. Take a screenshot of this or whatever, just for studying, and that's about it for reflections.